It's one thing to write code. It's quite another to know that it works. And another thing still, to be confident that your code is working in production as you intended it. To know what's going on in production, we need observability. Now, if we have observability, we can use that in development too. I want to show you in the next 10 minutes an example of using observability during development. First, the assignment. We have this app. It's called Sequence of Numbers because you push go and it gives you a sequence of numbers. At first, the numbers come quickly, but it gets slower. And that's a problem for our customers. Yeah, because they need more numbers now than they used to. See, if I open the browser DevTools, I can see this waterfall view of the requests going to the backend. These are the calls that are made, and you can see them taking longer and longer. Why is this so slow? All right, my team has already done the diagnosis on this. If you want to see the process, go do my Intro to Observability online course. I'm going to skip to the answer. Here's a graph of latency in the back end. Slower ones at the top. I'll click on a slowish point, and that shows me a trace. This is a waterfall view. The whole thing represents a request received from the front end, and each row represents a span, a unit of work, and a span of time that was part of this request processing. So you can see how long everything took. You can figure out what's making it so slow. We've determined that this index parameter is important, so I'll display it. This was a request for an index of 10, it looks like, the 11th number in the sequence of numbers. To calculate it, we did an HTTP request for index of 9. If I collapse that, I can see that the next thing was we did a request for the index of 8. You might begin to suspect the Fibonacci sequence, where each number is the sum of the previous two. Within the fetch for index of 9, we ask for index of 8 and 7. There's a lot of repetitive calls, and they return the same result each time for the same index. Our task is to cache these intermediate results. If we do that, I expect to see fewer nested HTTP gets. At least I won't see 2 for the same index. And I expect the response times to be faster. Code time. Here's our /fib endpoint and the response function. We're using OpenTelemetry here to send all these lovely spans and traces, so our code is nice and vendor neutral. All the spans we've seen so far are created by auto instrumentation libraries, and we add a few custom fields here in the code. Down here is the part where we fetch the previous number in the sequence and the one before that. That's the functionality we want to change. I don't always want to fetch the previous number. I do always want to retrieve it. So I'll make a new function called retrieve Fibonacci function that calls the old one. And then I'll call retrieve Fibonacci function instead in both places. Now I can change the functionality. Let's make retrieve use the cache. Make result a var. If it's in the cache, then that's the result. Else fetch it and also put it in the cache before returning the result. And then, yeah, there's a cache. Trust me on that one. Let's run this and see what it looks like. We'll generate some numbers. Then over in Honeycomb, I hit back, I run this query again, and I click on the most recent dots to get a new trace. Well, there's only one HTTP get. It looks like 13 fetched 12, but did it get 11? Did it get it from the cache? I can't tell. This is not observable. Not okay. I need to know what happened in every case. I need a span that shows we retrieved a number and whether it was from the cache. Okay, so I want retrieve Fibonacci number to make its own span. This is a little harder. To do this, I need a tracer, which I get from OpenTelemetry, and then I use that to call start active span, give it a name, and then I give it a callback, and that callback contains the work represented by the span. So put all this work in the retrieve function inside that callback. Oh, and then remember to call span.end right before return, because ending the span triggers OpenTelemetry to send an event to Honeycomb, and that'll put something in the trace. Okay, run it again. Generate some numbers, get a new trace again. I can see the new span. And here's another one at the end. It's much shorter. I'm betting we got that one from the cache. Dang it, but I can't tell quite. So 12 retrieved 11 by HTTP, but what index did it retrieve from the cache? I need to see that. It's time to add a field. Adding custom attributes to spans is easy as adding a log. Okay, while we're here, let's make it super clear where the result came from. Was it a cache hit or not? Oh, and while we're at it, let's add the result. This is an object, so stringify it. All right, run it again. Generate more numbers. And find a new trace. Okay, we can see the index now. And if I pick this span, I can see its other fields. Sure enough, this was a cache hit. I can see what the result looked like. Ooh, now I want to check that the result is the same in all cases, whether I got a cache hit or not for the same index. I'm going to find the name of the span, and I want to run a query over all the spans with this name. All right, here they are. Let's see what their index is and the results. I can use group by to get Honeycomb to show these to me. All right, here's the list of values. I can sort by index and look at the results. And there's only one result for each index, so they must be the same. I can add cache hit just to be sure. Put that in the group by. There's a bunch of blank ones. I'm going to zoom in on the most recent events so it only shows my latest test. And then let's order by index and whether it was a cache hit. Okay, results look the same for the same index. That's good. I can hover over these lines and see, okay, here we have one cache miss for index 0, then a cache hit, one cache miss and some cache hits, and so on. Only one cache miss for each number. That looks like it's behaving well. Of course, we won't really know until we get it into production. So let's push this up. And I'll let continuous deployment do its thing. We'll see what it looks like. So far, I've satisfied myself that the code works without any tests or any logs, just traces. Now, in real life, for any interesting business logic, I would absolutely write automated tests. But this isn't business logic so much as system interaction. Interaction with the cache, interaction with another service over HTTP. These are really painful to test and not that useful, because what matters is how that cache, the real cache, behaves and how that service responds to us. That's where observability is strong, especially in production. So let's go see how that deploy went. Okay, over in Honeycomb, I switched to the production environment and let's run a new query. I want the sequence of numbers service in the last 10 minutes. Let's count, and we want incoming requests. Trace.parentID does not exist is a spell for only requests coming from outside. The marker here shows the deploy. You can see, looks like we had some downtime. That's acceptable with this service. Deploys don't have to be smooth. Look at these counts. It looks like request counts have gone up. Let's check on the performance. I'll add a heat map of the duration of the requests. This shows me how many were slow and how slow they were. Whoa, take a look at that. Even though we're getting way more requests, they are so much faster. The durations before the deploy are all over the place, and after they're super low. Let's look at a trace and see if it's what we expect. Sure enough, we see the retrieve Fibonacci number spans. Now I'm confident that my code is running. That feels good. I see that this one is a cache hit. That's what I expected. I see the result. This looks great. Hey, we were getting more requests. What if that's because they're faster? Are people asking for more numbers now? I'll go back to our query and let's add a max of the index to see how high it goes. All right, this shows us the largest index requested within each 1 second window. And sure enough, we're getting bigger ones now after the deploy. Like, people are retrieving index 18, whereas before they stopped at 10. I think people are getting more numbers for their sequences because they don't have to wait. And this is the best part of observability during development. Well, in observability generally. As a developer, I can make a change and see that that change impacts the experience of customers. I'm Jessitron. I work at Honeycomb, and if you want to talk more deeply about this, schedule a chat at honeycomb.io/office-hours. I look forward to talking to you.